you have that same correlation, then we'd assume that it'd be around about that deep before you actually hit the hollow inside the planet. Now, also, too, when we're talking about the pressure differences, your second question, between the two planets, basically between the inside and outside of the planet, at the moment the pressure would be equal because the flood has occurred. But before then, the pressure would have been considerably greater. We still would have been able to have life evolving and living, and could probably survive the drop in pressure after the flood. But the pressure would be sufficient enough to sort of force out the entire inside of the ocean to the outside for a period of time while the flood was occurring, and then for it to flow back in. So that we are talking about perhaps not a huge difference in pressure, but certainly over the whole expanse on the inside of the planet, that is certainly adds up to a lot of force that can be exerted on that ocean.
Matthew or Kevin, is the planet in any danger because of the hollowness?
No, it's not, because matter centers around gravity. And if you had a massive impact into the planet and it pushed the surface in, the surface would then come back out to realign with gravity. And we know this by huge craters like the Calaris Basin on Mercury. The floor of that crater is still there. They're cracked crust, but it's following the convex curvature of the planet. In other words, after the impact, the surface of the planet returned back to its natural curvature. That is because it rebalanced around gravity. And this is one thing that we were going to say in the interview, we never actually got around to saying. But the floors of craters actually being convex instead of concave is another reason to support the hollow Earth theory.
Oh, that's a good point. Now, the book, The Land of No Horizon, how did you come up with that title?
Inside the Earth, there is no horizon, like we have on the outside of the Earth. And so that's where it came from. This is the land within, and it's a land without a horizon, so we called it The Land of No Horizon.
Let's go to our East of the Rockies line. Welcome to Coast, you're on the air with us. Hi there.
Hello, how you doing?
Good, sir. Go ahead.
I was just curious. You talking about this, water on planets, being hollow. I was wondering, what about the moon? They found water on it recently.
Yes, definitely the moon will be hollow as well.
I'll listen on the radio. Thank you.
Okay. All right. Good. Thank you. Go ahead.
What we've discovered is that when a body becomes, it gets to a certain size, it will start to become very spherical. And what we've discovered is that when this size is reached, that's when basically the surface effect, it reaches right to the center of the planet, and then all of a sudden the planet can start to become externally dense, and that's the cause of it being completely spherical. So you'll find that when you say look at the moons on Mars, Phobos and Deimos, they are rocky and they're oddly shaped, and that's because they're only small. But when you get larger, you find that the relative size of the gravitational attraction on the planet and the structure of the actual rock in the making up the planet, you reach a balancing point. When you get to a certain size, it starts to bend, and you'll start to get a very spherical body. And of course, as you go further, it will start to become hollow. And the moon is definitely hollow, and as are all bodies the size of the moon and up. But when you get to about 150 kilometers in diameter, that's when you'll start to get bodies that become more oddly shaped, and that would indicate they're not hollow. 80 miles, yes.
West of the Rockies, you're on the air with us on Coast to Coast. Hi there.
My name's Mike. I'm from Vancouver. I'd like to raise a question to your guest, Kevin. Tesla described the resonance period of the Earth as being 1 hour and 49 minutes. I wonder how that relates to his hollow Earth theory.
I'm having trouble hearing.
Yeah, I'm having trouble hearing him, too.
Okay, I'll say it again.
I'm having trouble with my phone.
And speak up really loud, would you?
Yeah, that's all right.
Tesla expressed a resonance period of 1 hour and 49 minutes for Earth, and I wonder how that related to the hollow Earth theory.
Yes, what's actually happening here is after an impact or an earthquake, the Earth rings like a bell, and it lasts for 1 hour and 45 minutes or so. And this is something that's been very difficult to understand in a solid Earth model, and this is why it's been such an interesting point that they keep bringing up. Because if the Earth was solid, we wouldn't expect that the resonating of that impact or that earthquake to be around for such a long period of time. But of course, when we look at this in a hollow Earth model, it makes perfect sense. That because it's hollow, the vibrations keep traveling around and around and around until they dissipate. And that is the reason why they last so long. So that's yet another reason why another thing to prove that the Earth is hollow.
Okay, next up, let's go back to our wild card line. You're on the air with us on Coast to Coast. Hi there.
Hi, my name is Paul, and I'm listening in Columbus on WTVN AM 610.
Hi,
and I
Paul.
had a question about magnetism. If
Sure.
you look at different pieces of iron, it magnetically aligns itself to where the poles were placed at the time that the iron had frozen.
Yeah.
And so if you look at the conventional solid Earth theory, the way that this functions is that the iron core magnetizes itself to the pole, and then when it hardens, it stays in that magnetism, and then we find it. And so we see the polar shifts, and I'm wondering exactly how polar shifts work in a hollow Earth theory and how magnetism essentially works in a hollow Earth theory. And I'll listen off the air. Thanks.
Yeah, we're not actually sure exactly what's happening with the dynamo theory, and there's a number of different areas of it, and they're trying to explain the magnetism effectively with this theory, but they're having problems with it. Some of the problems are if the Earth is centrally compressed and solid as believed, and it is super hot and intense and in intense pressure, they're not sure if under that intense pressure and heat, if the metal of the core can actually maintain a magnetic alignment. Because we know when we have a molten metal, you can no longer get magnetism from the molten metal because it no longer holds that polarity. Secondly, as well, in the center of the Earth, where you're actually in the center of the planet and the mass is evenly distributed around you, there will be no gravity or very little gravity in the center, and so it's very difficult to explain any convection currents that could be occurring to cause the magnetism as well. So it's another problem that we have. So there's quite a few things there, and I think I haven't researched the changing polarity of the magnetic field, but there's been certainly a lot of research into that on the Earth regarding the plate tectonics and the drifting of the continents, because we know that a continent, when the crust solidifies, it locks in that magnetism, and then as the continent drifts around the Earth, that magnetism then is drifting away from alignment, and we can tell just how far away these continents have drifted.
Matthew, have you ever seen any satellite pictures of the top of the planet which could depict where the hole is?
I have seen some satellite images, but one particular one that I remember seeing was actually a montage of many different photos of the North Pole. And what they had done is they'd taken photos of the North Pole during the winter time, and they pieced them all together, and it left a big black circle right over the pole. And I remember seeing this as an argument for there being a polar hole. But really all was happening was that this black area at the top of the pole was actually the area which doesn't receive sunlight throughout the winter. And so that was actually, it wasn't a correct case. But that doesn't mean that there aren't other photos or so on that could indicate something such as this. I have heard of also, because of being a hole in the crust and currents running through the North Pole, you can have warm currents bubbling up coming through from the inside, and they can have massive areas of ocean that don't have ice cover because the ice has been pushed away. And then this is one of the things that some of the early explorers in the Arctic have found, that all of a sudden they'll come across a massive area where there's no ice, and they can't explain why there's no ice when everything else is freezing cold. And certainly this could be observed from a satellite photograph. I haven't actually seen any photographs of this, of just accounts that people have seen these sort of things, but certainly they could be out there.
Let's go east of the Rockies. You're on Coast to Coast with us. Hi there.
Hi, this is John from Buffalo.
Hey, John. Welcome to the show. Go ahead.
Yes, I was calling to talk about an experience I had with the Hollow Earth, actually.
You did? Okay. What happened?
Well, what it was is I was on an expedition through Greenland. I'm a geologist, to study the effects of global warming on the ice caps. And When I was in north of Greenland, there's a friendly Eskimo village that actually said that they have a myth about the gate